Right? I think you guys can. Okay, cool. So let's begin the discussion. So hello everyone, welcome to today's webinar. Today we are going to have a brief overview and introduction about GitHub. Right? We will understand what is GitHub and how do we best make use of it. Okay, so I would expect the participants to already know what is Git, but I will throw a little bit of overview to just give you a recap of what is Git, because GitHub is a service based on Git. Okay, so uh, yeah, that's there. My name is Amit, and I'm based out of India from a city called Bangalore, and I will be taking this discussion today. Right? So let's talk about Git. What is Git and why do we use it? And then we graduate ourselves to GitHub. Okay. Git is it's a version control system. It's a version control system, and it allows you to track your software development evolution of your source code, right? So you start your software development, you have few files, few pieces of code in the files, but then as you grow, as you add more features, as you add um, more code, it becomes complex to track the changes which are going into your project, right? So Git helps you in tracking those changes, right? So how does it help you? Well, there is a inherent feature in Git called as commits. Okay, a commit is nothing but a snapshot of your code. You can say code, but it could be anything. Snapshot of your files, right? Snapshot of your project files. I would just put it like that. Snapshot of your project files at a point in time. So what does that mean? Let's say you have um, let's say you have a Java based project, right? You're writing Java files, and we have three files: a.java, b.java, and c.java. Right? Let's say you have three files, and your code goes in these three files. And you have many developers, right? Let's say you have developer A, developer B, and developer C, who are all contributing to this source code. Okay, and as and when your developers are making changes, you create snapshots. Um, well, you don't create. Git creates snapshots of the project at a particular point in time. For example, let's say developer A adds some changes to your project files, right? So as soon as developer A adds some changes, it creates a new version or a snapshot of this piece of code, right? So it might have a.java plus some changes, b.java plus some changes, c.java maybe no changes. Right? So it's a new revision or a new version of your entire code base. And then maybe developer B creates some more changes, and then that also goes as a.java, b.java, c.java. Maybe developer B added a new file, so let's call it as d.java, right? So as along with time, along with changes in your code, Git creates snapshots of the repository, and each snapshot is identified. Each snapshot is called a commit. Okay, as I mentioned, each is called a commit, and each commit has an ID. So let's say this is initial commit. It can have an ID 1, 2, 3, 4, 5, 6, A, B, C, D. So it's an alphanumeric character, which is a 40 character string. It is called a commit ID. Commit ID. So it's a 40 character string, 40 character alphanumeric string, and it is unique for each commit. Okay, so Git will randomly create these strings and associate them with your snapshots. And this is called as commit ID. So each snapshot, which is called a commit, gets a unique commit ID, right? So let's say this is commit ID 0, this is commit 1, commit 2, and like this you can build on build and build. Any point in time, you can come back and see what changes were made in commit 2. As and when a new commit is made, Git tries to remember who made the change. So maybe developer B made the change here. What was the change? So there should be a small summary or a message. When was this change made? There will be a timestamp. And what was changed? So there will be a summary of changes between C1 and C2, right? So all these details are captured by the commit. So, 2 years down the line, you make these and then you find a line of code which is problematic. Then you can go back to the beginning of the history of that project and find out who made that code change to bring in that line, and then maybe have them modify it or work around it. You'll get some context, right? So these are commits, and this is how Git helps in getting the revision of the commits. Okay, these errors are actually incorrect. So in Git, let me correct this. So every commit has information about its parent. Okay, every commit has an information about its parent. C1 knows that its parent is C0. C2 knows that its parent is C1. Okay, so it's kind of a reverse linked list. So from any commit, you can traverse back to its ancestors, right? Who was the parent, who was the grandparent, great grandparent, and all that. A parent can have more than one child, right? So let's say C0 was the initial commit, then another commit was made called C1, and from C1, developer B made another change called C2, right? At the same time, I'm sorry, I'm a bit under the weather. Please bear with me. So at the same time, developer B can also make a commit with the same parent, right? And they can have maybe some changes here. Yeah, whatever changes. We don't care about the changes here. And what happens here is when you diverge your commits like this, and then further commits will be made, right? And this creates a diversion in your commit history, right? And this is called as a branch. In Git, you can branch out your source code development. Maybe you are developing this for a production release, and you are developing this for a test release, right? Or maybe this is for customer 1, or maybe this is for customer 2. The purpose could be anything, but you can have diverging commit histories, and this is called branching, right? So C1 has two kids, two children, C2, and I would say, let's say T0, and then C2 can have another child, C3, C4, and these guys can have D1, D2. So from D2, you can access D1, D0, C1, C0, right? From C4, you can have C4, C3, C2, C1, C0. C4 will never be able to see what's happening in D2 because there is no way to refer it. Similarly, D1 can never see what's happening in C3 because there is no way to refer it. Correct? So these are called branches. And if we want, so when you work with Git, right, you can work with one branch at a time. Right? With Git, you work with one branch at a time. You do a Git checkout and then give the name of the branch. And then you can see all the changes that have happened in the branch. You will see the top of the changes right now. Similarly, if you check out this test branch, you can see all the changes since the beginning of time to the commits wherever these commits can reach for the test branch. But if you want to get these changes together, then you have to merge those branches. Right? So you have to get the changes from this branch, you have to get changes from this branch, and then merge the branches. Let's call this as M0, or maybe call it as C5. So you take changes from the branch test, merge it onto the branch prod, and you get a new commit. In this C5 commit, there will be all the changes from this branch merged here. And this is called as a merge commit. And a merge commit has two parents. Okay, a merge commit has two parents. And then you can create more commits here. It can go on and on and on. So this is how software development goes in Git. Now, unfortunately, this is not a Git session, it's a GitHub session. So I just want to give you this idea to introduce you to some of the features in GitHub and how they allow you to collaborate better and have all these functionalities in a more intuitive way, in a more user-friendly way, and in a way that you can make use of all the technologies that are, all the solutions that are provided by GitHub. Okay, so let's let's take a look at that. Now, before before we work, where do you make these commits? You make these commits locally, right? So you always have a remote repository. Your source code, your project code is inside a remote repository. What is a repository? Repository is nothing but a container which contains your project files, right? It could be source code files, it could be text files, readmes, documentation, whatever. That would mean a repository, right? So it is always on a remote server somewhere. And when you want to make some changes to this project, you get your laptop or a workstation or whatever, and you get this remote repository to your local system, right? And you get a local repository. A local repository is nothing but exact clone of the remote repository. So you clone it down. When you get local repository, then you can make changes to it, make commits, and then make changes. And whenever you want to make your changes publicly available to others, you can push those changes as well to the remote repository. Right? So you clone and then you make a commit here. You make commits on your local machine and then you push. Right? Commit happen locally, you clone from remote and then you push to remote. A remote repository is how other people will access the source code. Nobody can access the source code from your local laptop. So whatever changes you make, you should push them to remote. Now, how do you set up a remote repository? You can set up it multiple ways, but the easiest and fastest way is to create it on a GitHub service. Right? So you go to GitHub, you create an account, and then you get a repository, and you can clone it, make changes to it, upload it, do whatever you want to do. Okay, so GitHub is first and foremost a service on Git. based on Git, which allows you to manage remote repositories. Okay, and then on top of that, it gives you so many more features. Right. So let's take a look at how do we manage a repository on GitHub. Just give me 1 second. Right. So let me get my screen here. Okay. So this is my GitHub account. You can create an account on GitHub for free. So you go to github.com and you will get a page for sign in or sign up, and then you can create your account, and you can create an account for free. You don't have to pay anything. Once you create an account, you can see a dashboard or home page. I don't know what you see when you don't have anything in your account, but this is how it looks for me. Now, on the left hand side, you can see the repositories that I own. Let me zoom in a bit. Right. On the left hand side, you can see all the repositories that I own where I have put in some code. Okay, let's create a new repository for our discussion for this class, specifically for this class. So let me click on new, and here you can see a new repository, create a new repository. Now this is the GitHub's interface here. You can create a repository and you need to give the owner of the repository, which is my username, and give the name of the repository. You can give it anything. Let's say I will give it as my SkillUpRight webinar. Okay, and it says, hey, this repository name is available inside my account. There is no other repository with this name, so it is available, right? And I can give some description. This is optional. Anything which does not have an asterisk is optional. So I can give some description. I'll just skip it. Then you can specify who can access this repository. If you make it a public repository, then anybody can pull or anybody can see the files in your repository. Anybody can see who is making commits, what are the branches, what are the files in your repository. Everything will be public. But for making changes to the repository, they would need access. So not everyone can make changes, but everyone can see the contents of your repository. Okay, so that's the public visibility. You can also make it private. If you make it private, then for both reading the repository and writing to it, people need access. So only the users who can see this repository or who have access to this repository can pull it down. All right. Okay. That's the configuration. I'll leave it as public because it's just a demo repository. Then there is add readme. So you can add some default files while creating the repository. So first is add readme. You can add a readme document. So I can say, okay, add a readme file. Then add a git ignore. Git ignore is a special file which allows you to ignore certain files while making commit. So you can do that. You can add a license. So maybe I'll add a license as well. Let's say my whatever I'm creating is under GNU GPL. So I'll just use that. All this is optional. You can see no asterisks here, but I'll just do it. And I click on create repository. And now I have this repository. I'm inside the repository homepage right now. So before exploring here, let's go back. Let's go to github.com. And now you can see on the left hand side all the repositories. On the right hand side, this is the change log. Something has happened to my repositories, whatever. This information is coming from GitHub itself. Okay. And here is feed. So if somebody is doing something on my repository or some information from GitHub, it will come here. Now here on the left hand side, I can see all my repositories, right? Or I can click on this button here and I can see more details, and I can click on repositories here, which will take me through all the repositories which are in my account. Okay, these are all repositories in my account. And well, my contribution is where I have made commits, but this is my repositories. Okay, and here I can sort the repositories. Let's say last pushed, and you see this is a repository here. It is updated 1 minute ago. This is a repository which I created. I click on that and I'm back at that home page which I was showing you when it was created. Now there are a lot of things here which you can see. First, let's take a look at the top bar here, which are the global bars. So on the top, you can see my account name and the repository name. Here you have a search button, which we will come back to later. And then you have Copilot. If you have license for Copilot, you can use that. And here you have a create new button. So you can create so many things. You can create a new issue, which we'll see later. We can create a new repository or create a new gist, which is like a documentation, or a new organization. If I want to have collaboration between my teammates, I can create an organization or a team, right? So I can do that. Here is, I can directly go to all the issues in this repository. We will come back to that. This is pull request, and this is to list all my repositories here. So again, I'm back to the this view here, right? So that's the top bar. This is the repository specific menu bar. Okay, all the repository specific action. This repository specific actions are here. So first is code, which is self-explanatory. All your code files are visible here. Okay, so let's see if I can annotate in this. Okay, I don't find any annotation. Just give me a second. Let's see if this would work. Okay, so right, so this is the name of the repository, right? And here you will see the complete repository, directories and files. Okay, this is your top of the latest files in your repository. And if you have a README file, then this is it will open a preview of the README here as well. So README files are generally used for documentation. And if you have a README.md in your repository, then it will open it as a documentation here. So if you remember, while creating repository, we asked it to create a README. It created a blank README for us. So this is here, and that's what it shows. Okay. And here is all our code is here. Right now there are 2 files, there could be more. And now here, this is all your branches. You can see all your branches here. Right now we are at main, but we can change it to something else later. Okay. And here is a quick jump to a file. If you want to open a specific file, you can click here and go to that file. On the right hand side, you have an option to add a file. So you can create a new file. If you want to create a new file in your repository, so this option allows you to create a new file in your repository. But then again, that's an edit operation, right? You are updating something in your code. So creating a new file will create a new commit. Maybe you want to download this code in your local laptop and then work on it, make commits there, then push. For that, this is the button. How do you get the code is where this green button will help you out. Okay, so this is something that we are going to take a look at. Yeah, we will come back to more things later. But let's say I want to work on this repository. I want to clone this, make some changes, and then push here. Okay, so let me click on code button, and you can see here, if you want to get it on a local laptop, you can clone it via git clone command, and you can clone it over HTTPS, which is this URL, or over SSH if you have uploaded the SSH key, or using GitHub CLI. So GitHub also has its own CLI called GH. You can use that to clone the repositories also. What happened here? No, I don't want to do that. Right. Let's clone it over HTTPS. Okay, so I'll clone this URL and I will start with a terminal here. This is my laptop. Right, this is my laptop and I should have Git installed on my laptop. So if you have Windows, or I'm not sure if it comes by default in Mac, but on Windows you have to install Git. You can install it, just look for Git installation. Pretty straightforward, just download the exe and then install it. Okay, for Windows. And for Mac, I think it is already installed. So you have Git here, and now you can go to any directory. Right? For example, I can go to this directory and right here, and then I can just say git clone URL that I copied. Right? This is a URL that I copied from here. And as soon as do that, run the command, and it says cloned and downloaded stuff. And if I do a dir, I see SkillUpRight webinar. It's a directory. So I can go into the directory and I can see this is a license file, this is a readme file. And if I run the command git status, I can see that we are on the main branch and everything is fine. Okay, so this is how you can clone it. And if you want to make some changes, maybe you can create a new file. So I want to create a new file called a.java. I'll just add some text. Okay. And if I do a git status, you will see a new file is added. I'll do an a.java. And it is added now. I'm just assuming that you guys know what is add and commit and all. So I'm not going to explain what am I doing here, but you can, if you don't know what git add, git commit, git status, what are these commands, then you have to go back and learn about Git and basic Git workflow. Okay. So git commit, and I say adding a new file called a.java. So what I did basically was I added a new file a.java in the repository, and I am now making a new commit. That means I am creating a new version of this project. Okay, so I cloned the project from here, cloned into my local repository, a local laptop here. Now I made a commit, and then now I will make a push here. The push is going to take this latest commit, which I did here, the latest change, and push it to the remote repository. The remote is GitHub. Right? It will remember where it cloned the repository from, so it will push to that repository only where it was cloned from. Now, if you remember, when we did a git clone, it did not ask us any credentials, because as I said, it's a public repository, and public repositories do not require any authentication for read operations. But for push, let's try. See, it is asking us for authentication. So on Windows, it will say, okay, login. Either I can add my token or login. And I say, okay, I log in with my browser. I click on that. It will open here on the browser and it will establish a connection. Remember that. And now push. Okay, on your devices, the authentication process may be different. Maybe you get a prompt here for username password, or you get some other prompt. It depends what kind of Git credential manager you are using. On Windows, if you have installed Git, it will also install the Git credential manager, which will allow you to connect to the remote servers. Anyways, when you do a Git push, you can see to this URL, it has pushed and changes are here. If I refresh this, now you can see in my source code, there is a new file called a.java, right? Coming back here, in this line, yes, here you will see who made the latest commit, who made the last change, right? So Upshift now made the last change by adding, what was the message? Adding a new file a.java. This is the latest change. It was made 2 minutes ago. Okay, and you can see here there are 2 commits in this branch. So we are in the main branch. There are 2 commits here already. So let's quickly click on these 2 commits. And when I see, you can see there are 2 commits here in the main branch. Right, so this is the initial commit, which was the commit which was created when we created the repository. And this is the commit which I pushed from the local laptop. Right, and each commit, well, this corresponds to these, right? C0, C1, C2. So looks like we have C0 and C1. In C0, we had initial commit. C1 is adding a new file, a.java. And if I click on the this commit, new file a.java, I can see here who made the change. Upshift now made the change. It was committed 3 minutes ago, right? Its parent is this. This is the parent, and this is the commit ID. Okay, and this was the change. A.java was added plus. So this file was added. You can see it in green text. It was plus. Right? So this is how you can work with the code on GitHub. This is the code part. Now you can use GitHub to track and manage issues also. So if you are just a independent developer and you are developing a small app, or maybe you are producing large amount of code, but you want to interact with your customers for any issues they are facing, right? So then you can ask them to, or ask your customers, or you yourself can create issues and track them here. So this is like your project management or incident management uh, or bug tracker tool, right? You can create an issue, you can follow those issues, work on those, close them, and that allows you to interact with your customers as well, right? So you can click a new issue and then transition the issue to various states and then associate your code with the issues and all that. We'll come back to pull request. You can also publish a wiki, which is like a detailed documentation for your repository. We can do that. In the security, you can define authentication, collaborations, and all that stuff. So I'm going to skip that. Important thing is settings here. So when you created a repository, you gave it some details, you specified the visibility, gave the name and all that. You can always change that, right? So you can change this name to something else and click on rename to change the name of the repository. Then you can also change the default branch, which is by default main, but you can change to something else. You can also enable or disable features, right? For example, you can see issues. You can see issues here because it is enabled for our repository. Same wiki is also enabled for us. We can always disable them, right? Pull request, we'll talk about pull request in a bit. And at the end, you will also see visibility, right? You can change the visibility, which is currently public, to private. You can do that. You can also transfer this to another account. Right now it is under Upshift now. You can transfer it to some other account as well. Or you can archive this repository. That means it becomes read-only and no issues can be created, no activity can happen. If you are kind of retiring the project or the project is deprecated, you can do that. Or you can delete this repository as well, right? So when you delete a repository, gets rid of everything. All the commits, all the files, issues, everything. So you can do that. If you want to share it with others, if you want others to also push to this repository, you can go to collaborators and you can add people to allow them to push changes to this repository. Okay, so that's something that you can do. Important thing is pull request. Let's say you have this code here which is on the main branch, right? Now let's say I want to add a new feature here in this project. So what I do is I avoid putting everything in the main branch, because main branch is the branch which is supposed to have the stable version of your application, right? Which is tested, which is ready to be shipped, right? So I do not want to make any feature upgrades or feature changes in the main branch directly. So what I will do is I will create a new branch and I will make my changes there. Okay, I can call that as a feature branch. And once that is done, I can merge it into the main branch, right? I can merge it into the main branch so that my code comes here. But again, when I merge it, I'm updating the main branch. So maybe my feature is not ready to go to the main branch, but I anyways merge it. That's against the best practices, right? So rather than merging on my own, I can create something called as a pull request. When I create a pull request, that means I'm requesting someone to pull changes from my branch into the main branch or the target branch. In that way, somebody can review my code and review what I'm bringing in and then merge it to the main branch. Okay, so let me show you how you can do that. So right now we only have main branch. Let's create a new branch here. So I can, from here only, see it says find or create a branch. Let's say I want to create a feature branch. I type feature here. It does not find any feature branch. So it says, do you want to create a feature branch? I click on yes. So I created a feature branch. Both feature and main branch have the same content, right? Now I created a feature branch here. I can pull that branch in my local also. I just do a git pull. Git pull command pulls the latest changes from the remote repository. And you can see I have a feature branch here. I will check out to the feature branch. And now I'm going to make some change. Yeah, I'm going to create a new file called b.java. I add some text. Okay, git status. b.java is there. Git add and commit also. Adding b.java. So you can see here now I have I pulled the latest branch from GitHub and created a new commit. Let me also do a git push. Now it will not ask me credentials again because I already provided the credentials. So it's just going to reuse the credentials from that cache. Cool. Now here, if you see the main branch, it has these three files, but the feature branch has a new file called b.java, right? Now I can go to, let's say I want to merge this change from feature branch to the main branch because I want to propose this feature into the application. So I'm going to go to pull request and I can click on new pull request here. Although in the code tab itself, GitHub suggests that feature branch had a recent push. Do you want to compare and create a pull request? I can create a pull request directly from here, but I want to show you the whole process. So I go to pull request and then I can click on new pull request. And here I can choose the base branch, which is where the changes will go to. You see the arrow, but they will come from the feature branch, right? This is a source and this is the base branch. So this is the comparison. It tells me that b.java will be added here. So C plus 5. Now I can create a pull request. When I create a pull request, I can say adding a new feature. So this is a pull request. This is the title of the pull request. I can give more details here. Please add this to main branch. This is an awesome feature. Customer we make money. Yeah, whatever. So this is my rationale behind creating this pull request from the feature branch to the main branch. Now I can associate some reviewers here. Maybe I have a tech lead or I have a manager or I have a business partner who should review this code, right? Who should review this code. So I can add those reviewers here and then I can create this pull request. Now I did not add any reviewers or I'm the admin of the project, so I can directly say merge, but generally it's going to wait here and it will wait for somebody to review this. So here you will have list of people who will be allowed to review your code. And then when they review, they can leave some comments, right? They can leave a comment like the code is not good or it is failing. The style of coding is not good. This feature is incomplete. Have you tested it? Whatever. Whatever is the observation, it will be provided here. And then I can make more changes. I can commit more changes to satisfy the reviews. And once everything is satisfied, once all the reviewers are satisfied, they can approve it. And when they approve it, I will see this merge option. So I can merge this pull request. So when I merge, you can see here, when I merge, it creates a new commit called merge commit. That's what it's going to do. I said custom confirm merge, pull request successfully merged, right? So if I go here, code, and in the main branch, now I see b.java, and this is a user who has made the recent change, and it says merge pull request one from Shift Now feature. And I can see here 4 commits in the main branch. This is a merge commit. Okay. And you can see here it has 2 parents. As I said, merge commits have 2 parents. So this has 2 parents as well. And now I made some development in my own branch. I raised a pull request. It got approved. It got merged. My code is in the main branch now. This is a typical development workflow that we follow in the industry. It is standard across the industry. There is also a tool called GitLab, which is similar to GitHub. It is also a hosted hosted Git collaboration tool. It also has similar offerings. There could be different terminologies. For example, we call it pull request in GitHub. In GitLab, it is called as merge requests. And yeah, many things could be here and there, but more or less they work on the same principle. Right, I spoke a lot. Sorry about that. And I think we are almost at the end of the time. So do we have any questions? Any questions? You will have the recording in the recording will be available for you, and it will be made available by SkillUpRight. So yeah, question is how to use GitHub in CI/CD. Okay, so there is something called as actions. Actions is nothing but you can execute some code whenever there is a change in the repository. That's called GitHub actions. Okay, and GitHub actions will allow you to write any custom code which you want to execute. Maybe you want to compile your code, or maybe you want to trigger some other workflow. Maybe you want to do a Terraform apply, or you want to run some tests. You can do anything that you want using that code. So that's called GitHub actions. And it is similar to GitLab CI/CD. Okay. What do you mean by rebase? Okay, rebase is a Git concept where you want to update your branch by taking all the changes from another branch, like main branch. So that's called rebase. It requires some explanation. Unfortunately, we don't have this in the scope of the discussion, nor we have the time. So yeah. Do we get notifications when changes happen? Yes, you can subscribe for notifications to this repository. Although I don't recommend, because in the beginning it may sound like something you would want, but later you will realize it is just noise. How to get access of GitHub? You can just create an account on GitHub and create repositories. If you want access for some specific repository to modify it, then you have to reach out to the owner of the repository. How to add reviewers? The reviewers have to be collaborators in your repository, or they have to be part of the same team. Then you can add reviewers in the pull request. If we stash some changes and then delete the local repository, will the stash be lost? Yes, the stash will be lost. I'm not sure where it is stored exactly. I never dug deeper into it, but yes, it will be lost. What is the Windows PowerShell which you used? Oh, this is terminal. You can install Windows terminal, and that comes like this. Where testing of the code happens and who tests it? It depends on the team. You can write unit test cases in the code itself and execute with the actions. Or you might have a dedicated test team which will clone your project and then test it. It all depends on how the team wants to work. Do we have report on to know if code is modified and check in pending? Check in pending. Check in pending. Do you mean commit is pending? If the code is modified in somebody's local repository and the check-in is pending, is that the question, Ajay? Well, if commit is pending, it is on the local, right? It is on the laptop. So nobody will know what's happening on the laptop. You will not have anything. And you don't need to do that, right? When you do a git status, you will know that something is pending. So yeah. Okay, guys, we are almost at the end of the time. We are done. So thank you for spending time here. I hope I was able to add some worth to your knowledge. And it's all free. GitHub is free, so please log in and play around. There are so many interesting repositories as well. Maybe I should do a detailed session on GitHub Actions. So I can do sometime. Yeah, it's something which everybody wants. Right. Thank you, everyone. Take care. Bye bye.